Hello viewers, how are you? So today I am going to start scales. Okay, so we are having three types of scales. Suppose first one is reducing scale. Second one is enlarging scale. And third one is full size scale. Okay, so in the reducing scale we are going to draw the diagram, okay, which is comparatively having less dimensions from the original drawing. Okay, suppose if you are having some dimensions of 20 meters, okay, so 20 meters I can't draw in a drawing chart. So in that case we are going to reduce this 20 meters into some centimeters. Okay, so this suppose is in the ratio of suppose 1:1:100, or suppose 1:1000. In this way the ratio we are going to take. Okay, so suppose this one is suppose this is the dimension which we are going to draw, and 1000 is suppose this is the original dimensions. Okay, similarly in case of enlarging scale, if my object dimensions is very less and we are going to enlarge the dimensions, then it is called the enlarging scales. Okay, so enlarging scale suppose 50:1. Okay, suppose some object dimensions is suppose given 1 mm, 1 mm, 1 mm, 1 mm. Suppose cube you want to draw, so 1 mm, 1 mm cube you can't draw, it is very small size. Okay, so in this case suppose we are going to enlarge these dimensions. So this is enlarging dimensions. And last one is suppose full size scale. Here original dimension is going to be taken. Okay, suppose 1:1. Okay, so if my dimension is suppose 1 centimeter, so in the original in case of drawing sheet also I am going to take 1 centimeter. Okay, so there are three types of scales we can say. Reducing scales, okay, so which is going to reduce the dimension in the drawing charts. Enlarging scale, which is going to enlarge the dimensions in the drawing charts. And full size scales, which is keeping same dimensions. Okay, now we are having another term. This is called representative fraction. Representative fraction. Okay, so it is denoted as RF, representative fraction. Okay, so what is RF? So representative fraction is nothing but it is the ratio between length of the drawing. Okay, length of the drawing divided by actual length of the object. Actual length of object. Okay, so this is called representative fraction. So suppose if I am going to take one example, okay, suppose your original dimension is actual length, we can say actual length of original dimension is suppose 1 meter. Okay, so in that case what is your representative fraction? RF. What is RF? So in that case suppose RF equal to, if I am going to take 1 centimeter, okay, 1 meter equal to 1 centimeter in the drawings, okay, in the drawing chart. So here you are having 1 centimeter divided by 1 meter. Okay, so it is nothing but 1 centimeter divided by 1 meter means 100 centimeters. Okay, so your RF value is 1/100. Representative fraction is 1/100. So this is an example of suppose reducing scale. Okay, so for reducing scale the RF is less than unity, less than 1. Okay, so for enlarging scale, RF is greater than 1. Suppose I am taking one example. Okay, suppose you are going to draw. Okay, suppose your original dimension is suppose 2 mm. Okay, 2 mm, and you are going to enlarge this dimension, okay, into suppose 1 centimeter. Okay, in case of your drawing scale. So this is nothing but your 2 mm, and here this is 10 mm. Okay, so this is nothing but 5. Okay, so you can see that in case of enlarging scale, the RF value is greater than 1, and in case of reducing scale, so this RF value is less than 1. Okay, so in that case I can write, suppose the scale will be, suppose here 1:100. Suppose this is for reducing scale, and for this enlarging scale the scale will be, suppose 5:1. Okay, so this is nothing but the scales. So the length of the scale can be determined is using this formula. Length of scale is RF into maximum length required to be measured. Okay, so this is the length of the scale. Now types of scale. So first one is plane scale, diagonal scale, second one, third one is comparative scale, fourth one is Vernier scale, and fifth one is scale of chords.